to continue to identify and graph quadratics. Identify, by the way, how do we identify? What's the key thing about a quadratic? What's the key thing about quadratic? Good, that's the shape is a parabola, but how do I know it's going to be parabola? When I have a square. The square, not a cube, and not some other thing, but when it just has a square, we know instantly I'm going to graph a quadratic or a parabola. Okay, yes. All right, so now let's walk through the backside here. Now we did refresh ourselves, and we did spend a moment to figure out where that parent function came from. And the parent function, when I input a 0, outputs a 0. When I input a 1, outputs a 1. And that's symmetrical, so that means it bounces over on the other side, which means -1 also gives me a 1. When I input a 2, out pops a 4, which is right here. And the symmetrical part says, if I insert a -2, then out comes a +4 also. So there's my symmetric over there. So this right here is, my friend, the parent function. So on your page, pages 2 and 3, I put the graphs there with the original parent function. Why? Because every single new function that I get is a derivative. It is a child. It's just a newly formed graph that comes from that. So the basic shape will always be a parabola, but it might be squashed a little bit, it might be flipped, it might be whatever. So I'm actually going to do B first, in order, because there's less for us to consider there. All right, so what's the nature of this one here? Well, clearly because of the square, I know it's quadratic, so it's going to be a parabola. And what does the 2 tell me? It tells me two things. Which way does it open? Good, it opens up because it's positive. And we also know that it will stretch by a factor of 2. So it opens up, that's the first part. The second part is that it's going to stretch by a factor of 2. Now, how do I interpret? What does that factor of 2 thing mean? Here's what it means. Every single output from the parent function just gets doubled. Every output is doubled from the original function. So let's look down here. My original function, at 0, I get 0. So when I double 0, I get 0 again. No change. My original output here, when I input a 1, out comes a 1. However, when I double that, outputs a 2. Now it turns out, remember it's symmetrical, so the -1 will also output a 2. What's the output on a 2? A 2 outputs a 4. So what will it now output?
8.
I have to double that to be 8. So 8's off grid here, so I'm going to estimate it to be up there. And I'm going to symmetrify and put it over there. So notice what 2x squared does. It stretches it up. It stretches it up so that my new parabola is a little bit more tight.
Beautiful.
Thanks. As we look at letter A here, the negative right there tells me that it opens down. And the next part, the 1/2, tells me that it is, and it says that it's going to compress. Now when we describe that, we're going to say it something like this. It will compress by a factor of 1/2. And that's silly. There you go. It compresses by a factor of 1/2, which means everything from the original output is cut in half. Everything from the original output is cut in half. But as we also notice, it's going to be turned upside down. It's going to flip. So let's see. My original output right here is 0. So it stays 0 because half of 0 is 0. My original output right here, or even here, is a 1. So I cut that in half. And I flip it down to the negative. So now, instead of going to the negative 1, I go to the negative 1/2. Now what about this one up here? The original output was a positive 4. Flipping it would take me down to a negative 4, but I'm going to squash that in half to be right here at negative 2 for both of those. I could even go one more. I don't see it on the graph, but the 3 would give me a 9, right? Because 3 squared is 9. So if I cut that in half, 3 squared is 9, I now have 4.5 over here. So the 3 now gives me a negative 4.5. So notice how my graph and my curve is opened a little bit more. Look at the distance between these 2 points versus the distance between these 2 points right here. A little bit wider. How about these 2 points here compared to these 2 points here? A little bit wider, not much. As we look at the next 2 problems on part 5, we have an a, g of x, and a b, h of x. Describe your neighbor real quick. What's the fundamental difference between what these 2 look like, and how do we interpret that? So as we look at these ones here, this one is I have a subtraction that comes after the function. We also could say that it's outside the function. So that is a vertical shift. Specifically, it goes down 3. Well, if outside the function is a vertical shift, what's inside the function going to be? Not vertical, but
Horizontal.
it's a horizontal shift. In other words, this one goes left or right. Now, this one's the unique one. We always have to consider opposite. We always have to consider the opposite. So it says negative 4, but it means go right 4. So there is no change in the width of this, nor is there any change in which direction it opens. All we're saying is take this whole thing and shift it down here. So now it's going to look exactly like this, just underneath it. This one over here says take the whole thing and shift it right, so it's going to be over here. So let's go ahead and do that point by point. All we do is take one point, like this one for example, and shift it down 3. So there we are. Take another point and shift it down 3. And there we are. And I'll erase that point up there so that doesn't confuse us too much. Another point right here, and I'm going to shift that down 3. 1, 2, and 3. And I'll get rid of it so it doesn't confuse us. All right, find me another point. Up here is a nice clean point, and I go down 4, 3, 1, 2, 3, go down to there, and repeat the process here. Go down 1, 2, and there's my new point there. So let me clean that up and see what my new graph is right here. And there we go. It just takes the exact same function, this one right here, and shifts it down. No change in width, no change in opening. Next one here is exactly the same, except we shift it in a different direction. The negative 4, take the opposite, means I'm going to move everything to the right. Everything to the right by 4. So here's an original, my vertex. So all that does is go 1, 2, 3, and 4. There's my new vertex. Now I take this point right here, and I go over 4, to the right 4. 1, 2, 3, and 4 places here. Take this point and move 1, 2, 3, and there's my new point. Take this point right here. 1, 2, 3, and 4. Take this point. 1, 2, 3, and 4. Coincidentally, it happens to cross that other one at that exact same point that we had earlier. So now we need to make a nice little curve. So all I've done is taken my function and shifted it that way 4. That's it. Just move it that way 4.